Grade 9 Gravitation Part 2 Questions and Answers. Question number 1. Who formulated the universal law of gravitation? Answer: Isaac Newton. Question number 2. What is force of gravitation or gravitational force? Answer: the force of attraction between two objects is called the force of gravitation or gravitational force. Question number 3. What is centripetal force? Answer: it is a force which acts on an object moving along a circular path and is directed towards the center is called the centripetal force. Question number 4. What is the source of centripetal force that moon requires to revolve around the earth? Answer: the motion of the moon around the earth is due to the centripetal force. The centripetal force is provided by the force of attraction of earth. Question number 5. State the universal law of gravitation. Answer: every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. Question number 6. All the objects in the universe attract each other. 1. What is the force of attraction called as? 2. Name any two factors on which this force of attraction depends. Answer: 1. This force of attraction is called as force of gravitation. 2. Force of gravitation depends on two factors. A. It is directly proportional to the product of their masses. B. It is inversely proportional to the square of the distance between them. Question number 7. Define universal gravitation constant. Answer: the universal gravitation constant is defined as the gravitational force between two objects of unit masses placed unit distance apart. Question number 8. Who invented calculus? Answer: Isaac Newton. Question number 9. Who found out the value of gravitational constant G? Answer: Henry Cavendish. Question number 10. What is the SI unit of gravitation constant? Answer: SI unit of G is Newton meter squared per kilogram squared. Question number 11. The mass of the Mars is 6.39 into 10 raised to 23 kilogram and that of the Jupiter is 1.89 into 10 raised to 27 kilogram. If the distance between Mars and Jupiter is 7.49 into 10 raised to 3 meter. Calculate the force exerted by the Jupiter on the Mars. G equals 6.7 into 10 raised to minus 11 Newton meter squared per kilogram squared. Answer: mass of Mars M1 equals 6.39 into 10 raised to 23 kilogram. Mass of Jupiter M2 equals 1.89 into 10 raised to 27. The distance between the Mars and Jupiter D equals 7.49 into 10 raised to 3 meter. The force exerted by the Jupiter on the Mars F equals G into M1 into M2 divided by D squared equals 6.7 into 10 raised to minus 11 into 6.39 into 10 raised to 23 into 1.89 into 10 raised to 27 divided by 7.49 into 10 raised to 3 the whole squared equals 14.4 into 10 raised to 29 Newton. Thus, the force exerted by the Jupiter on the Mars is 14.4 into 10 raised to 29 Newton. Question number 12. Mention 4 phenomena that the universal law of gravitation was able to explain. Answer: the universal law of gravitation was able to explain successfully 1. The force that binds us to the moon. 2. The motion of the moon around the earth. 3. The motion of planets around the sun. 4. The tides due to the moon and the sun. Question number 13. Define free fall. Answer: whenever objects falls towards the earth under the earth's gravitational force alone, then such motion is called free fall. Question number 14. Define acceleration due to gravity. Answer: whenever an object falls towards the earth, an acceleration is involved. This acceleration is due to the Earth's gravitational force and is called acceleration due to gravity. Question number 15. Write the direction of acceleration due to gravity. Answer: the acceleration due to gravity is downwards. That means towards the center of the earth. Question number 16. Does velocity of a body during free fall remain constant? Why or why not? Answer: no. The velocity of a body increases at every point of its motion during free fall as acceleration due to gravity act on it. Question number 17. Give two reasons for the variation of G at the equator and at the poles. Answer. The variation of G at the equator and at the poles are due to difference in the radius and due to the rotation of the earth. Question number 18. Why does a body reach the ground quicker at poles than at the equator when dropped from the same height? Answer. The acceleration due to gravity is more at the poles than at the equator. So, when dropped from the same height, a body reaches the ground quicker at the poles than at the equator. Question number 19. Two solid objects of masses 1 kilogram and 2 kilogram are dropped from a helicopter at the same time. Which one will reach the ground earlier? Justify your answer with the suitable reasons. Answer. Both will reach the ground at the same time, as we know that an object experiences acceleration during free fall. This acceleration experienced by an object is independent of mass because G equals gm divided by r squared. As they are dropped at the same time, they will reach the ground at the same time. Question number 20. Give the equations of motion of objects under the influence of gravitational force of the earth. Answer. All the equations for the uniformly accelerated motion of objects become valid in case of gravitational force, with acceleration A replaced by G, as G is constant near the earth, so the equations are V equals U plus GT, S equals UT plus half GT squared, V squared equals U squared plus 2GS, where U and V are the initial and final velocities and S is the distance covered in time t. Question number 21. Give differences between acceleration due to gravity small g and universal gravitational constant capital G. Answer. 1. Acceleration due to gravity is the acceleration acquired by an object due to Earth's gravitational pull on it. Universal gravitational constant is the gravitational force between two objects of unit masses and separated by a unit distance from each other placed anywhere. 2. Acceleration due to gravity is different in different places on the surface of the earth. Its value also varies from one celestial body to another. The universal gravitational constant G is a universal constant. That means its value 6.67 into 10 raised to minus 11 is the same everywhere in the universe. Question number 22. Anu buys 200 grams of gold at the poles. What will be the weight of gold at the equator? Answer. Acceleration due to gravity is less at equators than at the poles. So, move from poles to equator, the value of acceleration due to gravity g decreases, and hence weight of 200 gram gold also decreases. Question number 23. Name the place on the Earth's surface where the weight of a body is maximum and minimum. Answer. Weight of a body is maximum at poles and minimum at equator. Question number 24. A car falls off a ledge and drops to the ground in 0.6 seconds. The value of g is 10 meter per second squared. For simplifying the calculation. 1. What is its speed on striking the ground? 2. What is its average speed during the 0.6 second? 3. How high is the ledge from the ground? Answer. Time taken t equals 0.6 second. Initial velocity u equals 0. Acceleration due to gravity g equals 10 meter per second squared. 1. Speed v equals u plus gt. V equals 0 plus 10 into 0.6 equals 6 meter per second. 2. Average speed equals u plus v by 2 equals 0 plus 6 by 2 equals 3 meter per second. 3. Distance travelled h equals ut plus half gt squared. H equals 0 into 0.6 plus half into 10 into 0.6 raised to 2 equals 5 into 0.36 equals 1.80 meter. Question number 25. An object is thrown vertically upwards and rises to a height of 13.07 meter. Calculate. 1. The velocity with which the object was thrown upward, and 2. The time taken by the object to reach the highest point. Answer. Distance travelled s equals 13.07 meter. Final velocity v equals 0. Acceleration due to gravity g equals minus 9.8 meter per second squared. Upward motion. 1. V squared equals u squared plus 2gs. 0 equals u squared plus 2 into minus 9.8 into 13.07. So u squared equals 256. U equals 16 meter per second. 2. V equals u plus gt. 0 equals 16 plus minus 9.8 into t. 0 equals 16 minus 9.8 into t. So t equals 1.63 second. Thus, the initial velocity is 16 meter per second and time taken t is 1.63 second. Question number 26. What do you mean by mass of an object? Answer. The mass of an object is the measure of its inertia. It is constant and does not change from place to place. Question number 27. What is the SI unit of mass? Answer. The SI unit of mass is kilogram. Question number 28. What do you mean by weight? What is its SI unit? Answer. The force of attraction of the earth on an object is known as the weight of the object. It has both magnitude and direction. It is denoted by W. SI unit of weight is Newton N. Question number 29. Give the relation between mass and weight of an object. Answer. Weight W equals mass m into acceleration due to the gravity g. Question number 30. Mass of an object is 12 kilogram. Calculate 1. Its weight on the earth. 2. Its weight on the moon. Answer. Given mass m equals 12 kg. 1. Acceleration due to gravity on the earth ge equals 9.8 meter per second square. Weight of earth we equals m into g equals 12 into 9.8 equals 117.6 Newton. 2. Acceleration due to gravity on moon gm equals g by 6 equals 9.8 divided by 6 meter per second square. So weight on the moon Wm equals mgm equals 12 into 9.8 by 6 equals 9.8 into 2 equals 19.6 Newton. Question number 31. Write a short note on thrust. Answer. Thrust is the force acting on an object perpendicular to the surface. The effect of the thrust depends on the area on which it acts. The unit of thrust is Newton. Question number 32. What is pressure? What is its SI unit? Answer. The thrust on unit area is called pressure. The SI unit of pressure is called Newton per meter squared, which is also called Pascal, PA. Question number 33. Explain why a camel walks easily on a sandy surface than a man, in spite of the fact that a camel is much heavier than man. Answer. Because of the large surface area of the camel's feet as compared to a man's, the force applied by the camel on the sand is lesser than that applied by the man. So, a camel can walk easily on sand than a man despite of its larger weight. Question number 34. Why cutting tools have sharp edges? Answer. The cutting tools like blades, knives, etc. are provided with sharp edges to cut the things easily, as the sharp edges has small area on which the force is applied, hence more pressure is applied. Question number 35. Force of 200 Newton is applied to an object of area 4 meter squared. Find the pressure. Answer. Force F equals 200 Newton. Area A equals 4 meter squared. So pressure equals force by area equals 200 by 4 equals 50 Newton per meter squared. Question number 36. When a floating body is pressed down a little, which force will increase at that time? Answer. Upthrust. Question number 37. A block of wood is kept on a tabletop. The mass of wooden block is 5 kg and its dimensions are 50 cm into 30 cm into 20 cm. Find the pressure exerted by the wooden block on the tabletop if it is made to lie on the tabletop with its sides of dimensions A 30 cm into 20 cm and B 50 cm into 30 cm. Answer. Mass M equals 6 kg. The dimensions equals 50 cm into 30 cm into 20 cm. Thrust F equals mg equals 6 into 9.8 equals 58.8 Newton. A. Area of length, area of side equals length into breadth equals 30 into 20 equals 600 equals 0.06 meter. So pressure P equals force by area equals 58.8 by 0.06 equals 980 Newton per meter squared. Area of side equals length into breadth equals 50 into 30 equals 1500 equals 0.15 meter. Pressure P equals F divided by A equals 58.8 divided by 0.15 equals 392 Newton per meter squared. Question number 38. Why pressure exerted by the solid and fluid are different? Answer. Solids exert pressure because of their weight. That means pull of mass by the center of the earth with an acceleration of g equals 9.8 meter per second squared. Similarly, fluids exerts equal pressure in all directions over the inner walls of the container in which it is kept. Question number 39. What are fluids? Answer. All liquids and gases are together called fluids. Water and air are most common fluids. Question number 40. Define 1. Buoyancy, 2. Buoyant force. Answer. The tendency of a liquid to exert an upward force on an object immersed in it is called buoyancy. 2. Buoyant force is an upward force which acts on an object when it is immersed in a liquid. It is also called upthrust. Question number 41. A bucket of water weighs less inside the well water. Why? Answer. A bucket of water weighs less inside the well water due to the upthrust exerted by the well water on the bottom of the bucket in upward direction. Question number 42. Define density. What is its SI unit? Answer. The density of a substance is defined as the mass per unit volume. The unit of density is kilogram per meter cube. Question number 43. A cork floats in water while the iron nail sinks. Give reason. Answer. A cork floats in water because the density of cork is less than that of water. This means that the upthrust of water on the cork is greater than the weight of the cork, so it floats. The density of an iron nail is more than the density of water. This means that the upthrust of water on the iron nail is less than the weight of the nail, so it sinks. Question number 44. State Archimedes' principle. Answer. When a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Question number 45. What are the applications of Archimedes' principle? Answer. Archimedes' principle is used in 1. Designing ships and submarines. 2. Lactometer, which is a device used to determine the purity of milk. 3. Hydrometer, which is a device used for determining the density of liquid. Question number 46. What is relative density? Answer. The relative density of a substance is the ratio of its density to that of water. Relative density equals density of a substance divided by density of water. Question number 47. Relative density of gold is 19.3. The density of water is 1000 kg per meter cube. What is the density of gold in SI unit? Answer. Relative density of gold equals 19.3. Density of water 1000 kg per meter cube. Relative density of gold equals density of gold by density of water. So density of gold equals relative density of gold into density of water equals 19.3 into 1000 equals 19,300 kg per meter cube.